Hello everyone, welcome to Engineering and Economy. I'm Dr. Nathan. In today's video, we are going to discuss about the difference between AC coupling and DC coupling system in solar PV system. So, when you look at this picture, we can clearly understand what is the difference between AC couple and DC coupling system. These two systems are available to explain or to connect the battery to the system. So basically, we are talking about how we are going to connect the battery and how we are going to charge the battery. These two things is very important because there are a lot of confusion going on how effectively we can charge the battery. So we are going to explain that what is more suitable, because the charging the battery is depend on your customer need. Some people they need to install the battery, some people they don't want to install the battery, because when we talk about the grid connected system, we don't want battery. Obviously we don't want battery when you have a reliable grid. If you have a reliable grid, then we don't need to talk about battery. But if you have your grid is not reliable, there are frequent power cut or power interruption, then you need to install the backup batteries. In that case, we need to talk about battery. And another case, if you want to go for an off-grid system, completely get rid from the grid, independent from the grid, then the battery is the main player. So then we have to talk about battery. So here, look at this. In this picture, we have a um, AC coupling system and DC coupling system. If you look at here, in the AC coupling system, we need to use two inverters. One is a solar inverter, another one is a battery inverter. Sometimes we use a hybrid inverter. So the AC coupling system is expensive because we are using two inverters. In DC coupling system, we are using only one inverter. This is the major difference in these two things. Many people wonder why we have two inverters, because even myself, when I visited the site, I before understanding these all things in my early days, I wonder why we have two inverters. In one house we have two inverters, because they have AC coupling system. When you look at their connection topology, you can easily understand, like when they have two inverters, they are going for a AC coupling system. And this is a very simple differentiation between DC couple and AC couple system. And another easily you can differentiate, in the AC couple system, battery charging is a last option. The option means, like in the current flow path, this is in the last step. First thing is you convert all the power to the AC supply. Then from the here you supply to the house. Then after supplying to the house, if you have excess power, that excess power will charge the battery. In this picture, the house is not shown in this picture, but all the AC power you send to house first. I mean, not all the AC power, whatever the house consumption, house demand is there, you supply to the house first, then send to battery whatever the excess. I mean, battery is charged by excess power. In AC couple system, battery is charged by excess power, or you can choose the grid to charge the battery. If you are using the hybrid inverter, you can select the grid to charge the battery. And if the grid energy is cheap, and sometimes grid in developed countries, the grid says that I'm selling the electricity cheap price when in the off peak hours. When the demand is very low, in the off peak hours, you can buy the energy from the grid in a cheap price. In that case, you can charge the battery using this cheap price grid's power supply. So this is AC coupling system. Charging is a last part. But in DC coupled system, look at here. The battery charging is the primary work done here. So whatever energy solar panels produce, first charge it into the battery. If the battery is fully charged, then we are discharging. If it is fully charged, then discharging. Discharging and sell it to the grid. Discharging and using the inverter, convert into AC and sell it to the grid or supply to the house. This is for the grid. Or depends on the demand. If the house has no demand, then you don't need to supply to the house. in the daytime. If your house has no demand or zero demand, you need to supply, you no need to supply to the house. Okay, you are selling to the grid. So this is what the main differentiation. We'll move on and talk a little more about this. When looking DC couple versus AC couple system, the major difference is that AC couple system require two inverters. That's, I repeat again. Other system require, DC couple system require only one inverter. This is the first differentiation. And these suited for different scenarios. These two systems are suitable for different scenarios. Okay, then we can interchangeable. We can modify this two system and make it suitable for whatever we need. The choice of which system you should use is depend on the pricing. It's a price also matters, because AC coupled system price is a little bit high because we have two inverters. In another point, DC coupled system, we are wasting some part of energy because in the daytime we are charging and discharging, charging and discharging. So charging and discharging is happening in the daytime, so we are wasting some energy in the DC coupled system. So both system has advantage and disadvantage. I'm spending please listen, I'm spending a lot of time here because this is opening the door for the research. Okay, many people doing research to come up with a different algorithm, how to program the hybrid inverters, how to smart way of energy management, battery management, inverter, how to modify the inverter function, and like a hybrid inverter with the control option. So a lot of things going on with this. So this is a advanced topic. That's why we are spending a lot of time here. So the advantage of AC coupled system is that it's simple. AC coupled system simple, and anybody looking to upgrade an existing solar PV system, you can include the energy storage, because the simple things, then you have a grid connected solar PV system. Okay, at the moment you have the grid connected solar PV system, you are running the house fine, everything is going on. Suddenly you experience a lot of power cut in your country. Let's say you have a lot of power cut. Problem is your grid is going off and on many times. Then you got frustrated, you got angry. Now you are going to install the battery. So now you already using the AC coupled system, because whatever solar panels is produced is converted to the AC and supplied to the house. That is your current system. Now you can easily add the battery. So that is one of the advantage, because most of the houses you already have the AC coupled system, because you only have a panel, solar panels. You don't have a batteries. Batteries only about 5 to 10% of people having batteries. So you already have a AC coupled system. So adding the battery is easy for you. Okay. The DC coupled system, what is the advantage of DC coupled system? When you use power from the solar panels immediately, but DC coupled systems are significantly more efficient when need to use the batteries. Whenever you need to store the battery, as I said, DC coupled system is more efficient, because DC coupled system your charging is important. Okay. Okay. Then direct battery charging, that is one of the thing in the DC coupled system. Um, in power outages, batteries in the AC coupled system can become depleted and shut down the entire system due to complexity of the inverter setup. So if the power shutdown happens, then the AC coupled system sometime because of the inverter setup, if the battery is fully depleted, then you cannot get the power. But in the DC coupled system, it is easy when the power shut down, because we already said the DC coupled system is more suitable for the off-grid system. It can supply the power. Okay, now the full power utilization. AC coupled system usually use undersized inverters, because it assumes the solar panels will rarely produce full output. Okay, that is a reason, because many installers, they are saying like you can install little more size of panels compared to inverter. Let's say 1 kilowatt of inverter, they can invert 1.2 kilowatt of panels, solar panels, because they said that solar panels will never not always produce the maximum peak the the stated demand. Okay, sorry, stated power generation. Okay, in the STC, standard test condition, at the standard test condition. In a DC coupled system, the full capacity of solar panel can be utilized by directing excess power to the batteries. Okay, DC coupled system, what is happening? All the energy, the power produced by solar panels stored in the battery, so that it is fully utilized. Okay, and additionally, in the case of DC coupling, the DC to AC ratio can be higher. In other words, for the same capacity of the PV array, you can use the inverter with a lower output without reducing the amount of electricity generated. Okay, so DC to AC ratio is high. Now, which solar plus storage is more suitable? Okay, as I said, whether you already have solar panels installed. If you already have solar panels and inverter, you already running a kind of AC coupled system. Now you can easily install the hybrid inverter and the battery, so that your AC coupled system is fulfilled. But if you are going for the new type of installation, you can go for a DC coupled system. And if your daytime load demand is low, if your daytime load demand is low, then you can go for a DC coupled system. That's all for this video. So we this is two system available, because if you go into the any industry sites, you can visibly see whether they have a AC coupled system or DC coupled system. You can ask the people whether you have a two inverters or one inverter, and you also have to ask what these two inverters are doing. Then they may not know, but you can understand it's AC coupled system. We have a two inverter. One is probably they put one inverter outside, one inverter inside the building. This is usually I saw in many places. One inverter outside, one inverter inside. Okay. The second inverter is doing the charging the battery. The second inverter's job is to charge the battery. First inverter job is to convert all the generated power from the panels to AC. So we come to the end of this video. Please subscribe this channel and provide your support. Then only I can create such a nice presentation, and we can discuss deep knowledge, and it's a knowledge sharing, and it's helpful for you to learn things very quickly after watching this video. If you have doubts, you can comment me, and you can search in the other websites or the books, and easily you can catch up the rest of the things if I left out not explaining anything. Thank you very much. See you in the next video.